Okay, so today we are going to we're doing our quiz right for 6.3, and then there's one thing I do want to talk to you folks about, and then we're going to do we're going to skip the own population to anomaly actually, and then we're going to go straight to a little tiny bit of review. Tuesday, today, you have Connect Math 6.1 due. Thursday, you have Connect Math 6.2 due. I would strongly recommend if you're taking the exam on Thursday that you do this before the exam on Thursday. As much as you can, get as much as you can of 6.2 done before the exam. Also, I'll eyes up here for a second. Don't forget, for 6.2 and 6.3, use 2 decimal places for your z-scores. If you round to 3 decimal places, you will not get the right answer. Okay, and then Sunday 6.3 is due. Exam 2, you can either take it this Thursday or next Monday, either one, I don't care. You can take it at 2 o'clock, 5 o'clock, or 7:30. Again, I don't care which time, anytime you want. Yeah?
What section is the exam covering? Like, is it covering all of 6?
So it covers, that's a good question. I think I have it on the next slide, possibly. Also, quick comment. There will be a review session Thursday at 2 o'clock, and also another one at 5 o'clock next door. And I'm going to give her, I've made little handouts with like 5 practice problems on them that she can go over with you folks. And they're not the hardest. It kind of fills in the blanks from the stuff so your quiz covers a chunk of stuff that I feel like you may have forgotten how to do, and then that kind of fills in some more of the stuff that you might have forgotten how to do. Okay, good. So I did not see it on there. All right, so the sections that are covered are all of Chapter 3, all of Chapter 5, 5.1, 5.2, 5.3, and then Chapters 6.1, 6.2, and 6.3, not 6.4. So I would say the first, so all Chapter 3, and then 5.1 to 5.3, and I think, I believe all of Chapter 5, and then not 6.4. Yeah. There are 2 parts. Don't forget there are 2 parts. So the first part is a basic calculator like this. The second part, you will need to use a TI 83 or 84 calculator. You get 1/2 page of notes handwritten by you. And again, you can use 1/2 page on the top from your exam 1, and then 1/2 page for exam 2 on the lower half. That's totally fine. I can tell the difference between the 2 materials. And even though you can use TI 83, 84, I still need to know what numbers you use. So, for example, for binomials, right? Some of you folks know how to use a calculator to do it in your calculator, but you still have to give me this. 5 choose 3 times 0.63 to the third times 0.37 to the second, and then whatever your answer is. This is just showing your work. You need to give me that. Right? You don't need to say 5 factorial divided by what. I don't care about that. But give me this, and the answer, and I'm happy. Good? So that's good. Now show me the rest of the steps, but you need at least this. You can if you want, but you don't have to. I need to have at least that. Okay. And also, bring your binders with your quizzes, your in-class quizzes, the ones we've done, all your classwork basically. Quizzes in order in one section. In a different section, all the notes done and in order. Okay, so here's an important concept. What are the range of values that z-scores can be? Yes?
For the notes that you want us to turn in order, is that in the order that the chapters were in? Or by the lesson that we did? So I know we did like chapter 3 after 4.
Right. I don't care about 1, 2, and 4. You do not need to have 1, 2, and 4 present at all. They can be somewhere else. So usually in the order that we did them in.
Okay, thank you.
So those you can leave at home or whatever. I just need to see 3, 5, and 6. That's all I care about.
Okay.
Yeah, good question. Thanks. All right, so everybody please think about what's the range of values that z-scores can be. So in other words, what's the lowest a z-score can be? What's the highest a z-score can be? So think about it for 10 seconds, just on your own. What's the lowest a z-score can be? What's the highest a z-score can be? Just think about it. And then think about what are the range of values that areas underneath the curve can be. So think about the area underneath the curve. What's the lowest an area? That an area underneath the curve, under a probability curve, right? A normal curve. What's the smallest an area can be? What's the largest an area can be? If I said find the area under the curve for a situation. Okay, talk to your neighbors about this for 30 seconds.
Oh yeah, I guess. It's not 140 section mean, I guess it would potentially be. Because it can't keep going, it has to be 0 at some point. I thought. Yeah. Yeah, well, the range of values of the area, I would assume it would be like, it's no area, or like it's all of the area, so that's the area. Or I guess that would be my guess.
Okay, so what's the smallest a z-score can be? Negative what? Negative infinity. Right, remember that z-score way over there in the picture? What's the highest a z-score can be? Positive infinity. So remember, z-scores are along the bottom of our drawing when we sketch a normal curve. So the numbers along the bottom. You go all the way from negative infinity to positive infinity. It's like a number line. And then my area underneath the curve, what can that be? What's the smallest it can be? 0. What's the largest it can be? 1. 1, because remember the area under the curve is the same thing as what? Probability. 0 to 1. So that area of my curve, that's limited, right? It can only be, the total area of the curve is equal to 1 or 100%. So any area can only be between 0 and 1 at the very most. So make sure that you kind of keep those straight in your mind. And that's why I really insist that you keep your z-scores and your x values along the bottom on separate lines. You keep your areas above. Because it's one more way of helping keep things straight in your head of which part's which as you're learning stuff. When I show you, the kind of the steps of things, try to keep writing all those steps. Right, because some people, I noticed last class, they weren't writing z equals, and they just would write them, and then he got totally confused. It was like, wait, this is over 1, but it's a probability. It's like, no, that's a z-score. So if you write z equals, then you remind yourself, oh yeah, this is a z-score, and you'll get lost or confused about things, right? So try to keep things labeled and straight so that you can help your mind keep them straight as you go through them, and you don't get them mixed up. Because it's easy as you're learning, right, to get them mixed up. Okay. Applications of normal distribution. So if you want to find the area between the two x values, first convert your data values, your x values, to z-scores. Then draw a picture, put in your z-scores, shade between them, and then use normal CDF to find the area between the z-scores. That was the first problem. Let's get a reader for this one. Eric, go ahead and read.
Assume that adults have IQ scores that are normally distributed with a mean of mu equals 105 and a standard deviation of sigma equals 20. Find the probability that a randomly selected adult has an IQ.
Okay, that's fine. You can stop there. Perfect. Thank you. So first of all, is this central limit theorem or not? Talk to your neighbors 30 seconds. Is it central limit theorem or not, and how do you know? Okay, so the answer is no, but why? The question is why? Why is it not central limit theorem? Talk to your neighbors, 15 more seconds. Okay, what's one way I know that it's not central limit theorem? Yeah.
It's not asking for a sample or like a subset kind of.
Yeah, it's, because it's the, so there is no sample? Is that what you're saying?
Yeah, it's just a randomly select, but they're not saying a sample of.
Right. There's no sample size. No sample or there's also no n, right? There's no sample size. Does that make sense?
Yeah.
Great. What's another way I know?
The normal distribution.
That's not distributed.
It's asking to find the probability of a selected value.
Right. Find the probability that a selected adult, one selected adult. Does that make sense? So I'm not finding the probability of a mean. I find the probability of just one person, which I think would start touching on what you were saying too. It's not. You're not finding the mean of a sample. There's not a big group. So there's no sample, no n, and you're finding the probability of just one person, just one guy. Right? Not a sample of 30 people and their mean. So that's how you know it's not a central limit theorem. Okay, or conversely, that's how you would know if it was central limit theorem. Okay, so then less than 133. How do I know this is a normal distribution problem? How would you know on an exam this is a normal distribution problem?
On this problem, it says that it is.
Yeah, it says normally distributed. Right? So the only way that you know this is a normal distribution problem is if it says it's normally distributed. Unless you've got some central limit theorem going on, and then you could maybe get by without that. But basically, if it's a basic normal distribution problem, it will have to say normally distributed. Okay, so here, less than 133, find all your pieces. And maybe get used to writing them down somewhere. So here I've got my mu is equal to 105. My sigma is equal to 20. Here my x is equal to 133. So I find my z-score. 133 minus 105 divided by 20. Angelo, what'd you get?
1.4.
1.40. So then you draw a picture. Put in your notch. 1.40, is that going to be on my left or my right? Michaela, left or right? 1.40. Is it below 0 or is it above? It's on the right. Argument is positive should be on the right. 1.40. And then, I don't know, Lauren, am I going to shade to the left or the right?
Less than, you want to change the left.
Perfect. Did you hear what she said? She said less than. So less than means to the left. So you said that's what you said?
Yeah.
Good. So then shade it. Great. And then last step. Austin, what's my last step? I just shaded. I drew my picture of just 1.4. What's my z-score on the far left? Jesse, what's my z-score on the far left?
Negative infinity, so you can take the value, so negative 100.
Yep, negative infinity, any large number, so negative 100. I'm going to do a negative 600 just in case people throw a decimal place in there somewhere for some weird reason. And you will get, what'd you get? What'd you get?
0.919, or I can't read my own handwriting.
I didn't.
Something.
992.
I
That's
don't know
correct.
what you were saying.
Perfect. All right, more than 112. Same thing. Does anybody need 2 minutes to finish the second one? Somebody? Yes? No? Okay, take just 1 minute. Finish up B if you have not finished up B. look at the next one. More than 112. So find your z-score. 112 minus 105 divided by 20. Omar, what'd you get? 3.5? 0.35.
Oh yeah, 0.35.
No worries. And then draw your picture. Near spot. Diego, is it going to be on the left or the right?
Right.
The right? More than 0. And then I'm going to change to the left or the right. That way. Wait, which way?
To the right.
To the right. Okay. I was like, wait, you're that way or mine that way? Okay. All right. So, Daphne, what's my z-score then? What's my other z-score way out here? Positive infinity. So then what's my next step? You're going to do normal CDF of what?
35.
Great. And Francois, what'd you get?
I got 0.632.
6, 3, what?
3,
Ah,
0.36.
3, 2. All right, perfect. So the areas, I'm going to put them on the inside. So 0.3632, 0.9192. So you'll see the z-scores, or the x values, they go along the bottom. They go here. The areas of the probabilities, they go inside or above. Keep them straight so that you don't mix and match them. If you start putting the z-scores above, then you're going to start mixing up and saying, oh, it's 35% is the probability instead of the z-score. You see it? You see what I'm saying? And people will do that. So keep them separate and always in the same spot so you know which one's which. All right, to find a z-score or an x value, given an area. So what we've been doing is we've been feeding the calculator z-scores and we're getting an area probability. The inverse of that is when you give it an area and it gives you a z-score. So here, this is using inverse norm. That's the inverse of normal CDF. You feed it an area on the left, it gives you the z-score that goes with that. So what do? Draw a picture. Don't shade. So for the inverse norm, don't shade. Find the area on the left of the value you want. Then use inverse norm of the area on the left to find the z-score that goes with that. And then, if necessary, convert that x score to a z-score to an x value. So this is quiz problem from last time. If you need extras, they're over there. Find the z-score where 0.0158 of the population is less than this. This is quiz problem, actually it's quiz problem 4, I'm sorry. Quiz problem 4 from last time. So you're going to draw a picture like this, and then 0.0158 of the population, that's a probability or percent of population, is less than it. So less than is that on the right side or the left side? Which one is it? Less than. Is less than over here or over there?
Left side.
It's this way, this way, right? So you're going to draw in this, and this side is going to be 0.0158. I'm putting it on the inside, so you know it's a probability. I need to find this z-score. You're going to do a similar thing with the one down below. Top 25%, is that going to be on the left or the right? Top should be over that way, right? Remember, you got to find your left z-score for this. All right, so everybody take a minute. If you need one of last class's quiz 3s because you can't find yours, they're over there against the wall. So take 2 minutes at home. Go ahead and pause for a bit, and then come back when you have done this. So just to clarify, on the exam, you can go to the review session and then take and like at 2 o'clock or 5 o'clock, and then take the exam at like 5 o'clock or 7:30.
Oh.
Right, so if you wanted to, you could do the review at 2 or 5, take the exam at, you know, the next slot, right? The next 5 o'clock, 7:30, whatever you want. If you want, you can go to both exams at 2 o'clock and 5 o'clock, and then take the exam at 7:30 if you wanted to. I mean, it's just yeah, it would be all right. Okay, so let's go ahead and go over these ones here. So here we would do. What did you do? What did you do? Isla, how do we solve this one?
Here's the picture, you have the thing where you just use the inverse norm of 0.0158.
And what did you get?
Negative 2.15.
2.15? All right, so negative 2.15. So put that into your picture where it belongs. Did everybody over here get negative 2.15? Put it into your picture. Good. All right, next one. 25% of the population is greater than or equal to it. So does 25% go on the top or the bottom?
The top.
Top. So it's going to be over here. Which means what's on the left? 25%. 0.75. So this time, Lauren, what did you do for this one?
I did the inverse norm for 0.75, and I got 0.6745 as my z-score.
0.6745. So again, we're going to round our z-scores to 2 decimal places, so we put in 0.67. Good? Thank you. All right, so then moving on. The next thing we covered last class was uniform distributions. What's up with the uniform distribution? Well, it's shaped like a rectangle. The beginning, the probability is 0 up to a point. And then the probability goes straight up and is even and equal for a distance. And then after a certain point, the probability is 0 again. So here, less than 2 minutes, that will never happen because it takes me at least 2 minutes to buy a ticket. More than 10 minutes will never happen because I never wait more than 8 minutes for the bus or train or whatever it is. So, but between 2 minutes and 10 minutes, it's all equally likely. It's uniform, the same. So same probability, which makes this distribution a perfect rectangle. So what's the height of this distribution? Well, first of all, what do we know about the total area underneath this curve?
It
Equals 1 or 100%, right? So we know that the area inside is 100%, and what is the area of a rectangle? Length times width, or in this case, length times height. So we know that the length, I call it the big L, so the total length, is equal to what? Is equal to 8, right? 10 minus 2. Everybody with that? Okay with that part? Here I'll put 10 minus 2 equals 8. I know the length times the height equals 1. So I know that 8 times the height equals 1. So the height must equal 1 over 8. Good? So 1 times 8 is 1, 1 over the reciprocal. So the h equals 1/8. 1/8. So then the question is, what's probably going to take between 4 and 6 minutes to buy tickets and catch the bus? All right, so between 4 and 6, here is 6, 4 is there. So I'm going to draw my little, I like to draw rectangles. It's just easier to kind of see it all. I do that. And then I know that my height is 1/8. How far is it from 4 to 6? 2. So it's going to be 2 times 1/8. And you'll get, and I'm fine if you write. If you write 2/8, I'm okay with that. If you write 1/4, I'm okay with that. If you put 0.25, I'm okay with that. If you put 25%, fine too. I don't care. Any one of those answers is perfectly acceptable. I don't care. I just want to make sure you understand this concept. Right, the height times the little length. I call that the little length that I want, little L, as opposed to the whole length, big L. right, and then the next thing, oh wait, do folks want to talk to your neighbors about this one for like just a minute, or is everybody good? 30 seconds, or? 30 seconds, anybody? No? Yes, no? Going once, going twice?
Yes.
Yes, 30 seconds, talk to your neighbors.
For the